Wikicast Podcast.
Welcome to the second episode of the Wikicast Podcast. As usual, I'm your host, Steve O'Gallagher, and once again, I have the very capable genius who knows everything about everything ever, Adam Pollard. Is that fair to say?
Well, I think that's an overstatement, but I'm
Hang on.
flattered.
If that's an overstatement, then we're in big trouble because I've got nothing. So.
Well, this is going to be an interesting Wikicast.
Excellent. Well, this, as we said last week, this episode is going to be about the beginning of the universe, which is, I don't have to tell you, that's a heck of a topic. People dedicate their lives to that.
Yeah, I nearly said, where do we begin?
Hey!
But
that would be a cheap laugh, Adam.
yeah,
And you wouldn't do that.
no, never.
Yeah, the beginning of the universe. Now, there are very many theories into how the universe came to be. The most famous one probably is the Genesis book of the Bible.
Credible, very credible.
Credible. Credible insofar as
It's incredible.
it is incredible. It is what
I mean,
it is.
we're not here to
Oh no, absolutely not. I'm saying it's credible because it is liked by many people, and it brings comfort to a lot of people as a potential reason.
and
Ultimately,
it was one of the first ones.
Exactly.
And you never get everything right the first time.
ultimately, we don't know the definitive answer. What we'll talk about today is the
I hadn't even thought about the possible powder keg of this topic.
yeah, I hadn't either.
hadn't. We've jumped straight into the deep end with this one.
Straight.
I was
into
ready
deep
to
end.
go on about how much I like Brian Cox,
Yeah, no, we can do
but
it.
we're
later.
gonna hit it hard and talk about.
religion. No, we're not. But
No.
but what we're going to talk about at length today is the theory, and it is still just a theory, that has the majority of consensus in the scientific community.
Yeah, this is going to be very much to do with the science,
That's it.
rather than.
Yeah, religion is a completely different.
That's a separate
thing,
podcast. That's a separate.
which we may
topic?
or may
Yeah.
not do. We'll see. But yeah, so at the moment you may have heard of the Big Bang theory, which is the leading theory.
The one I learned when I was quite little, I think.
Really, when was that?
Well, I think we must have touched on it when I was in primary school, which would be elementary school, most places.
Yeah, I suppose.
I think that you're introduced to that pretty young.
Yes, because
I mean, it's a big bang, which all 8-year-olds
love.
are gonna love the sound of.
But interestingly, I've heard that it's incorrect to think of it as an explosion of sorts, because the problem is it's quite, and we'll get into this later, but it's quite a uniform, quote unquote, explosion. Which
Are
explosions
explosions not? No.
no. I mean, there's kind of chaos theory in that, but wow, we're already getting a bit
Yeah.
over our heads. But according to Wikipedia, the Big Bang model basically explains that the universe expanded from an extremely dense and hot state and continues to expand today. A common analogy explains that space itself is expanding, carrying galaxies with it like raisins in a rising loaf of bread. Which is, I think, rather poetic and beautiful.
Poetic. I don't think it's helped me understand
No?
the.
How that relates to the universe.
Yeah,
Perhaps
I
not.
think.
Uh,
I'm gonna be the layman in this episode, having studied politics, and
Great.
having a genuine but probably misguided interest in science.
a misguided interest?
Well,
I'm gonna be misguided. Maybe misguided knowledge.
yeah. There's gonna be a low fact ratio coming out of my mouth.
That's
today.
excellent. We should, as this is only our second episode, we should definitely set a precedent of a low fact
low fact
per minute ratio. But so basically, the Big Bang is it's the belief that the universe was once this really tiny focal point of extreme density that then exploded outwards
So
to
it's-
create this huge thing.
Not the idea that there was nothing beforehand.
Well, this is the problem because we can't look beyond the Big Bang. We can't know what happened before that because
But
we can't
but if-
see it. We can't measure it. We can't. I mean, we're lucky even that we can ponder about what happened before 200,000 years ago because humans have only been around in any recognizable form for 200,000 years. So so one way of knowing what we know about the world would be through, I don't know, word of mouth, and that would only take us 200,000 years. And as we know about word of mouth, that's extremely infallible. No, it's not. Fallible? Fallible.
Yeah, fallible. I think so.
So yeah, but luckily, scientists are very clever, and you can measure certain things that you can see from Earth, and then do experiments on those measurements to then gain knowledge from that.
Yeah. Well, I think I've already had my knowledge shaken.
Really?
I think my layman's understanding of the Big Bang was there was nothing, and then it's explaining. I mean, maybe I'm thinking of the universe the wrong way, but in my mind, it is the beginning of reality. It's the beginning of this reality, the beginning of time.
Sure. I mean, it is.
So is the consensus at the moment that there was something before the.
No. The problem is that we don't know either way. We don't know if there was something or if there was nothing. But it does. The Big Bang does suggest that in whatever that moment was, it did create not only space but also time itself, which is a complete mind melt of a concept. But that's to do with kind of like general relativity and space time and very, very odd, complex things. But this is the inherent problem, is because we live our lives on this Earth, and we can only see from this vantage point, unless you're an astronaut, and then you can see from space stations and stuff.
Slightly.
Yeah. But
fractionally more wide vantage point.
But from the dawn of kind of human quote-unquote intelligence, I mean, we kind of forget about this because we live in very large cities with city lights, and you don't actually see the stars that often. But if you imagine if you're out in the countryside when there are no lights, stars are just everywhere. I mean, it's as big a part of your day-to-day life as the sun is during the day. And so naturally, the people way back in the day would measure where the stars are and notice that actually they rotate slowly through the sky.
Which is where we get constellations, and
right.
They're like the rudimentary observations.
Yeah, some stars are brighter than others, and sometimes it's because they are bigger, hotter burning stars, and sometimes they're just closer because it's a three-dimensional space.
And sometimes planets. I mean,
the universe is full of all kinds of things. I mean, it's so hard to know just by looking up what's what and what what's close, what's far away, what's bright, what's not. But there was a great man called Edwin Hubble, did some very interesting measurements about distant galaxies. Now what he found was the farther away a galaxy was from us, as viewable through telescopes and very powerful telescopes, the faster it's moving away from us. And this is true about all stars and all galaxies beyond our own galaxy of the Milky Way, because obviously stars within our Milky Way are rotating the same way that we are. But beyond us, everything's moving far faster the farther away they are. Which, if you reverse, it
surely
means...
this depends which direction you're looking.
No, this is in all directions.
But
that was the amazing
we're not
thing.
The focal point, though, are we? Surely everything should be moving faster and faster away from the center.
But this is what really surprised them.
This is the mind melt.
Yeah, because we're not moving towards anything or away from any perceivable point. Everything's moving away from us. And we know that we're not the center of the universe because we can see other galaxies in very random order. So it stands to reason that everything is moving apart fast from everything else.
Whoa.
At the same time. Like, we don't know where the center of the universe is.
But if there's someone between me and you, they can't be moving, and they can't be moving away from
both of us. If if there's someone between us, you're running in the opposite direction from me.
But then there might be someone behind me that I'm running towards.
But they're also, this is the problem, they're also running away from you.
So then you can draw it back to a focal point. Which you just said we are.
In theory, you could, because this is the whole theory of the Big Bang, is that if you trace it back at a certain point in time, everything would have been in one place. We don't know where that is because we could be very close to the center, quote unquote, or very far away, but we can't tell because everything's moving away from us.
So, I mean, I suppose the image I've got in my head is a galaxy, the disk.
Yeah.
So we don't know what the shape of the universe is.
No.
Does it have it? I assumed it was a big disk of disks.
Well, this is one of the questions people try and figure out. Is it infinite? Is it finite? But it's a three-dimensional explosion of sorts.
Okay, now you're making it sound like a 3D Space Invaders game, where I go off the side and come on the.
Oh well, see, if everything's expanding in all directions, but from a singular point at which it all was once, then there can be no way of going out far enough to then be